Hello, Rob Lejeune, Greg Everett here today, talking about bad surface finish on your milled zirconia crown. So, Greg, we're looking at a milled crown out of the mill. Obviously, the sprues are still on it. And so this is the surface finish just on what the mill has given us. And maybe for some people, they view this as kind of like the way things are. And, you got to finish them down and make them look, better by hand. And obviously technicians understand that, you got to have some handwork to make things better. But with your passion and knowledge of how milling could be, how good a milling surface could be, let's show that next picture here on a good surface finish. And I'm betting there's people out there that won't believe that this is directly out of the mill. Like you can vouch for that. Like you would raise your right hand and put your hand on the Bible and say that I pledge that this is out of one of your mills. Is that correct?
Yeah. We help a lot of people with mills, and it's kind of sad to see out there what is accepted in labs and in clinical environments as good enough, and what the normal expectation is, and oftentimes it's surprising to people how clean a crown really can be off of a machine.
Well, let's go back to that good looking one. I mean, would you say that from your perspective, this picture is normal? Like this should be normal, or is this the unicorn that comes out that you just got lucky on?
No, this is what people should expect to be getting. I guess the point I'm making is that if you poll 10 people making zirconia units, I'd venture to say that 6 or 7 of them are not getting this type of thing.
So let's go back to the bad one. And so just tell me, like, where do these striations come from? What's the root cause as to, why this doesn't look so great? And then how easy is it to fix it? Like, what do we do to get from this mediocre at best looking crown or bad looking crown to the good one that you showed?
Yeah. So without going, super nerdy deep, I'll try to touch on the biggest contributing factors. You kind of have to put yourself in the point of view of the machine itself, and really what you need to get a clean cut is its rigidity. And so when you don't have rigidity, you get vibration, and vibration causes bad surface. And so the question is, okay, how do we get, vibration? There's a few things that can cause that. One, which is what we're addressing most of the time here, is a physical problem with the machine. There's a component that's worn out, or, something's broken or bent or misaligned, and it allows vibration to occur, and you get a bad surface finish. If you have a broken machine, that's one. But I think what's more interesting to people who might be watching this is, what can I do to help with surface finish? And so there's 2 things that are within control of the end user if you're getting something like this. One, which is super easy, low hanging fruit, is maintenance. Are you following your manufacturer's maintenance schedule on the machine? Are you servicing the collet? Are you calibrating it? Are you keeping it clean? Is it within its preventative maintenance window? These are all things that are always outlined in your machine's documentation that came with it, and or explained when a machine is installed, hopefully. So maintenance, if a machine's out of maintenance and it's got a loose collet or a worn collet or out of calibration or something like that, it'll absolutely cause issues like this. And so, first line of defense is check all those boxes, make sure that the machine is as pristine as you can get it as an end user. Now, that's, relatively nice low hanging fruit there for you. The second thing that's within control of the end user on these machines is the actual burrs, the tooling. In fact, there's a bit of some people call them burrs, some people call them tools. They're actually called end mills if you really want to get technical. But
Okay.
these little guys that are they're actually in contact with your part. they have a gigantic influence on your service. And so I think that it'd be good to bullet point what you want to look at when you're talking about tools. So the number one thing to keep in mind is a tool or burr is not a tool or burr. There's a variety of them available for every machine, ranging from the OEM factory and down to like the cheapest Chinese thing you can find on eBay or Amazon even. There's a giant spectrum of quality. What often happens is people get a machine into their office and they'll start cutting some units and then they'll realize, man, these burrs, they're expensive. These tools are expensive. They can be upwards of $150 for one.
Right.
And typically a tool, a machine to make crowns is going to have like 3 or 4 tools in it. And so you look at it like, man, that's affecting my bottom line. I'm going to look for a cheaper option. And you jump online and you find something that's, I don't know, might be $60, $70 online, and it claims that it's compatible, and you buy it because you think you're saving money. And yeah, you will save some money on the upfront for sure. But oftentimes that tool, even though it'll fit in the machine and it'll function, there's nuance to the geometry, the profile, the way the cutting flutes are designed. All of that plays into how you're going to get better surface finish.
What's a cutting flute, Greg? I don't know what a cutting flute is.
I don't know if my camera can focus or not, but if you think of a cutting flute, is you can think about it like it's a knife edge that's kind of spiraled around the side of the tool and around to the tip. And it's the edge that is actually doing the splitting of material. And there's tons of geometric aspects to that are different from tool brand to tool brand.
So it's the digital profile of the shape, the geometry of your specific tool. And so then if there's a slight variance in that profile between, the cheap replacement tool that you found on eBay versus the one that's programmed in your CAM software, although it's maybe close, the variance is enough to get a result like this. Is that what you're saying?
And 100%. You kind of brought me to a point I was working towards, which is, does the tool that's physically in your machine match what is represented in your CAM software, your nesting software? So the software that you use to bring your STL file in and put it into a disk and make a cutting program, it has a digital representation of this tool. And if it doesn't match perfectly, you can get all kinds of
Give me
problems.
what that means. Give me what matching, how many microns of accuracy between the digital profile and the tool itself? Like, how close do those need to be?
They need to be as close as possible. So the biggest thing is, like you mentioned, the profile of it. So if the profile, like the cross section, the shadow of the tool doesn't match what's in the software doesn't know how to avoid hitting things with it. And so you can get collisions.
Sure.
Collisions are catastrophic. They destroy things.
They break parts, but
they break tools, parts, and machines. A collision bad enough will break your machine.
How close does that digital profile, in reality, what does it need to be?
It needs to be dead on. I don't allow any tolerance for that.
Like 5 microns, 10 microns.
I mean, we're within the accuracy of the machine would be the right way to answer that. So if your machine's capable of 5 microns, then your CAM software should be within 5 microns. And so the way to technically answer that would probably vary from machine brand to machine brand, but it's when you're programming this stuff and you're putting this stuff in the software, it's real easy to use the right dimensions, and it's just not hard. We're not thinking about tolerance. It's a nominal thing. You're putting a dimension into a table and representing that tool. And what happens oftentimes is, you buy a cheaper tool and it might have a shorter or a longer feature that does not match that profile, and then you can get a collision.
So that's if I wanted to buy cheap tools on Amazon, let's just say I wanted to be successful with that, then I would also need to download a digital profile from the
Yeah, and
manufacturer and then load that into my CAM software, right?
yeah, and what you'll find is that zero of the tool manufacturers provide that.
Well, that was going to be my next question, right? How often do they just say like, XYZ compatible tool because
Yeah,
it'll plug into your spindle, or what do you plug in the tool into? Is it the spindle itself?
yeah. So yeah, so here's a spindle here. The tool is going to go into the collet here. It opens up and grabs it. So it's pretty easy to make a tool that'll fit. The diameter of the tool just has to match the diameter of the collet, then it'll fit in the machine. That's it.
Hmm.
Not very high requirement there. And so, if I would challenge, I would be very surprised to find an aftermarket low dollar end tool provider that could readily provide you with those profiles. They might be out there, but I've never encountered it. And so if you do want to use a cheap tool and be successful with it, you have to have somebody who knows the software come in and make you a profile.
Hmm.
And that can actually be more costly than just running the correct tools, because at that point you're paying for somebody's highly skilled labor and service to do that. So we want to make sure they match. And the easiest way to make sure they match is to buy the brand of tool that is in your software or that your dealer provides you or what have you, that they've already done that work.
And they've got an accurate profile that represents that tool.
Yes. And I'm not sure how much detail you're looking to get into, but that's the profile, the fit of the tool is only one part of the software. The other part is the cutting geometry itself. How many flutes does it have? What's the helix angle of those flutes? And all of that stuff contributes to the performance of the tool and how it actually cuts material. A good way to maybe compare it would be, if you're like a woodworker or something and you're using a dull saw or a sharp saw, you can feel the forces, the different forces in that cut.
Yeah.
Your machine feels the forces too. And it's crazy. I'll go into a lab and I can hear the bad tooling because
Oh,
it
really?
resonates. Oh, it's audible. You can absolutely hear it. It'll have a
Only you,
chattery or
Greg. Only you have eardrums trained to that. Well, let's move your
yeah.
screen to the optimized crown, just so we're
Yeah,
looking
there
at
you go.
that.
Yeah.
That's funner to look at than the other one. So good tooling, good cam, right? Or a cam strategy that matches your tooling. What else could go wrong? Like, what else should we be paying attention to that could cause that rough surface finish?
So I circle back to any source of vibration. And so cam profile strategy, if that doesn't match the material and tool, you can get vibration, which causes bad surface. And I've probably detailed that out enough. We can circle back to maintenance. The biggest issue with maintenance is collet maintenance. So the collet is the part inside the spindle that holds the tool. And every single machine manufacturer has a collet maintenance procedure, every single one. And the reason for that is because that collet is in charge of holding that tool secure and centered so that it doesn't wobble and run out and cause vibration and bad surface finish. So, Rob, it's crazy how often I'll ask somebody who's complaining about bad surface finish, hey, what is your SOP for collet maintenance? And I'm greeted with this dumbfounded look. What's a collet?
And you're saying collet maintenance is important.
Oh, it's
And
super important. Yeah.
honestly, Greg, I just learned what a collet is on this call, a minute ago.
Cool. Well, the thing, like, okay, so like you pay, $30,000 for a machine, right? And you were not educated on what a collet is. Like, oh, terrible.
No, the collet, it should just work right out of the box. I mean, that was going to be
Yeah,
one of my questions. Is this how a crown will look out of the box with a brand
right.
new mill?
Everything's brand new. Yeah. This is
Okay.
if you don't get this result with a new mill, you have something wrong for sure.
Okay.
But when I get my my new car, it's got new car smell. But if I never change the oil in it and never wash it, eventually it's going to be embarrassing and it's going to break down. And for $30,000, you've got a car sitting behind you. maybe not today. Used to be a car.
Yeah.
But like, man, when I got my first, new car, I was out there every weekend waxing the thing and making sure it's immaculate, no fingerprints, just because that's the mentality I have. But, this equipment gets abused because, I think there's an expectation out there that, yeah, you plug it in and you forget about it and it prints you money.
Mm.
And it does if you're nice to it. And it'll continue to do that if you're nice to it. And
So
so,
then,
yeah,
so what happens then is it just slowly drifts,
yep, you'll get drift for
and
sure.
you kind of get used to that slow drift, and then it gets to a point where you're like, these aren't the way they used to be. But then
Yeah.
my guess is the average person doesn't know how to diagnose and fix why it drifted.
Oh yeah. Yeah. And my company, Rob, we're here to help people with this sort of thing. And the vast majority of inquiries, I would say in the 80% are, hey, I'm getting lines. Why do I have lines in my crowns? And then we start this discussion. Hey, where are you at on maintenance? Where are you at on call it? Where are you at on calibration? Is the machine clean? And then if they've checked all those boxes, then we'll go, okay, let's do some troubleshooting. We'll mill some diagnostic parts and try to understand if the machine has a physical mechanical problem. Then if it does, then we figure out how to fix that and make a plan and get the customer back to what we're looking at here on the screen. The crazy thing is that vast majority of the inquiries we get are surface finish, and if you take that segment of inquiries, most of them are solvable by the end user, and it's maintenance or tools.
I
That's
was
it.
I was going to ask, to that point, if it's solvable by the user, how often could you help diagnose and solve this problem remotely with just like a virtual call?
50% of the time, 60% of the time. Because what, when we go back and look at this, if a customer shows me this, there are actually only a couple of types of flavors, I call them flavors, of surface defects. And this particular one is tool chatter. So instead of the tool cutting, it's glancing off the surface. And it's doing that at 30,000 RPM. So that ends up being a vibration. And okay, why is it glancing off the surface instead of cutting? In most cases, it's because let's assume that everything is good on the CAM software, everything matches. You have a worn tool. I have a dull tool making a glancing, sort of vibratory chatter mark. And if I use this metaphor, Rob, you have to tell me if it's good or I need a different one. But like, I got my block of cheddar cheese, right?
Mm-hmm.
And I got my super sharp steak knife. It just goes right through it. It's beautiful. I get a clean cut. Or I try to just cram the handle of that steak knife through the cheese. What do you get? You get trauma.
Yeah,
Uh,
exactly.
and so there's no difference between that steak knife and a cutting board. It's just smaller and it's running at a super high rate of speed. But a cut is a cut. We're cleaving one material into two pieces, one piece into two things, and we're just doing it, thousands of times a minute. And so, if we're talking about doing this remote, first thing is we're going to interview you about, what are the issues? What are you getting? I'm going to ask you all about your maintenance stuff, and the whole time we're listening and we're taking note. And then if everything is good, then we're going to move on. I'm going to look for imagery of what your mills do. I'm going to say, hey, take me some images. The better quality, the better we can read the tea leaves. And we can look at those images and say, okay, you got chatter marks, or you've got offset lines. And that's like when the top and the bottom of the crown have shifted. Or you've got belt lines, which is there's a consistent line all the way around the height of contour. Those different surface defects are caused by different things. And so when we look at an image, we can zero in on the root cause, and that takes the troubleshooting in a direction. And like I said, oftentimes it's something that we can just advise remotely, and the end user can take care of it, and they're back off and running.
Give me an example of one of those things that you could advise remotely that they could do on their own to optimize?
I'll tell you about a nightmare actually that's kind of related. So we're going through this entire. We had a customer that called and they're having a similar issue to what we're looking at, and so we go through this entire maintenance discussion and ask them about their tooling, and they promised brand new tooling. The machine is. We just put the burrs in it, like it's not the burrs, and so we gotta believe the customer when they say that, and so that case, the customer printed up the machine and shipped it to us all the way across the country. So we've got $1,000 worth of freight and a bunch of downtime. When it arrived here, we put it through our check-in process, and we analyzed the tools that were in the machine, and they were just hammered. They were hammered. Their entire issue was caused by dull tools.
Wow.
And we put new tools, quality tools in the machine, and it made this. It made a crown like this. So there was nothing wrong with the machine, and that case could have been resolved remotely, but it wasn't. And when we did the CSI breakdown on the situation, it was actually an employee who thought he changed the tools and promised that he did, but he
old
actually
tools
didn't.
in.
Yeah.
Okay.
Yep. And so
there's an obvious one.
There's an obvious one, right? Yeah.
What about collet maintenance? Can you troubleshoot that remotely?
Oh, yeah. Yeah. Well, so let's say they ask, what is a collet? Then we'll go through and we'll say, here's how you clean a collet. And we've actually got a YouTube video up now going over that. And it's like, run this, do this procedure correctly, and call us back if the problem reoccurs. And we usually don't get a call back from those customers that didn't know what collet maintenance was.
So collet maintenance is pretty easy to do on your own once you know what you're doing, and that can solve some of these problems. It's
assumed that the dealer trained you on collet maintenance when the machine was installed. And it's sad to say that that's often not the case. So yeah, collets, which is under the category of maintenance, and tooling. Those are the two big ones.
All right, if those are the two big ones. Is there a third, or is it just another group of a bunch of other small stuff?
Well, we could dive into calibration. There's errors that come from calibration. So every machine has a calibration technique or method, and there's an interval that's been dictated or should have been dictated by the manufacturer. And a lot of times it's not followed, or the procedure's not being done right, and so you'll have the machine. They say that you calibrated it, but if you didn't calibrate it right, now the machine's operating on an erroneous calibration, and you're getting bad results. And you think, well, hey, I calibrated it, it's fine. But no, you calibrated it slightly wrong. You skipped a step, or it was dirty, or it didn't. There's some issue with how it was done. And so that we do have a segment of cases that are from calibration related issues as well.
Okay, awesome, Greg. Well, thank you. Go back to the beautiful crown. So if these are the results that you want and want to keep, it's a good tool, a new tool, mapped correctly to the software, the CAM strategy, collet maintenance. So if you just did those things, then your odds of successful milling go up, I'm assuming. And obviously, if your mill is really old, then they can send it into you for service.
Yeah, I think you summarized it well, and I like to get on a rant sometimes, so it's good to have somebody bullet point things at the end for me.
Well, this is really good, Greg. Thank you for sharing your wisdom. If any of you out there want to book time with Greg, he's available at rebel3d.com/Greg, and he can spend time with you remotely, troubleshoot some of these easy wins. And, if you end up needing to send your machine into him, he can help, but he can do quite a bit remotely, prevent you from having to be down and out of a mill for days or potentially weeks. So thank you, Greg.
Yeah. Anytime, Rob. Always fun.